Hello, my name is Yui, and I'm from Team 9. Today, I will be demonstrating our final project. Uh, yeah, and I'll be the first one to present. The feature I will cover is image display. And to give a quick introduction about the feature, uh, image display is a core feature for user interface. Image display is a core feature for user graphical interfaces, and for our project, we will implement an image display feature that displays an image that is larger than the screen, and we will also allow users to scroll up, down, left, and right using the keys on the keyboard. And also, we're using an image capture device to capture images and display it uh, on the video recording app of our laptop. Okay, I'll start. The first file we need to look at is the big image.h. This file stores the color data of each pixel that will be displayed on the screen. And let's see how it is handled by the functions in frame buffer.c. Um, let me find that function. Oh, it's here. Is draw image v2. This function is mainly responsible for transferring data onto the screen and yeah, for the image to be displayed. It accepts the starting X and Y positions, ending X and Y positions, and the image array from earlier. It first clears the buffer and then it will go to this do DMA function to copy the memory and then start the DMA. Yeah, to copy the memory to the screen and then start the DMA. And now let's look at give me a moment. Now let's look at the function that will be called when we want to display an image. It's called the big image function. This is just the line that will be printed out on the terminal. Okay, first it uh, starts by reinitializing the frame buffer to match. Yeah, first it starts by reinitializing the frame buffer to match the dimensions of our physical screen, which in this case is this. Oh, sorry, is this is 2080, 1280 and 720. Next, it will clear the frame buffer and then it will call the draw image v2 and pass in the big image. And the draw image v2 function will copy the image from big image.h to a back buffer and from the back buffer to the frame buffer. By using this approach, we can minimize screen flickering and ensure that the user will have a smooth image display. And this function is simply for users to scroll up and down, left and right on the screen. This is for when users want to exit the function using Control and Z. Okay, now I will demo the display screen feature. We'll start by typing help to see the available commands, and it's in this command, big image. And if I press enter now, the selected image should be displayed. It's this one. If I want to scroll down, I'll hold S, and it should scroll down. Unable to set virtual offset. Yeah, if I want to scroll, I'm still scrolling down. If I want to scroll up, then I just need to press and hold the W key, and it's scrolling up again. It reached the X limit, so it says this. If I want to scroll to the right, I can press and hold the D key, and to the left, I just need to press and hold the A key. Yep. Okay, that's it for my part.
Hello, my name is Ngon. I'm a member of Team 9. Now I will explain the function that can can display the short video on the screen for several second time. You can see the function play video have the so function like ramp buffer release and ramp buffer init that create the new ramp buffer, and then we create the current frame with value uh, is equal to 0 that had the function clear and buffer. Next, for the while loop, the uh, we have the C parameter value the create the and the input of user. Uh, if the user reach the control plus 6 plus the that exit the screen and the short video will disappear. Or if the user don't reach anything, the short video are available on the screen. Now I will show you the demo. In the comment, we put the play video. You can see on the screen, the short video is displayed, and now, if I read the control with Z, the video will disappear and the screen turn back black. Next, I will show you the function that can display the team member's name with different color on the screen. You can see we create the function greenfish messenger display that can display the um, team name, team member names with different color as the green, yellow, blue. Now I will show you the demo. For this function, we on the fix. Yeah. Now you can see on the screen there are four team name member with SID of each people and each bring different color for each name.
So hi, my name is Wang. I'm from Group 9. So I'm going to talk about the task 2 and the task 3. The task 2 is about learning new stuff, and we are choosing DMA because we think copy a large of memory, like the image and the icon of the game, is taking very large amount of the CPU usage. So we're going to use DMA. DMA is actually a hardware related thing. So you have to initialize first to make it to work, like a bunch of functions I have provided here. And we have also have the timer, just a little timer function that to get the tick of the system, so we can calculate the time actually needed to copy a memory between CPU and the DMA. So is DMA is actually have a control block. So it's gonna read from that and set up the copy process like in our provide tutorial right here. So to illustrate how the DMA work, we're gonna run it. Actually, the interesting thing is on QEMU, the DMA run very slow compared to CPU. So as you can see right here, CPU take only around 300 milliseconds, but the DMA actually take like 6 seconds just to copy 20 millions of integer. However, on real bar, like we have tested before, DMA is blasting fast. It's vice versa, of course. Like 6 seconds for CPU, and the DMA it just take only 100 milliseconds. That's blasting fast. So here we are continuing to talk about the task 3 of about the writing the development of the app. So we choose a game, of course, and our game it's just a knockoff of the Chicken Invader. That's very famous for you guys in the 2000, I guess. So because the game using DMA to copy, so it's run very poorly on QEMU, like I show here. It's surprisingly laggy. So we're gonna demo it on real board instead, just to notice that. So the flow of a game. So after like you type game, it's gonna check on the argument that you have in the game. For example, like you type game hard mode, it's gonna read hard mode and put it into attribute of the function game logic. It's gonna run game logic. So if it's a hard mode, it's gonna set it to hard mode. So first, it's gonna initialize the game, like some basic value of the game, like your life, how many space shuttle, how many chicken life they currently have, and the compare value that you can get for the chicken to randomly shoot at you, and create a bunch of objects about the game. Initialize first, of course, and after that, the game gonna run into the big loop. It's gonna continuously running into this unless you want to exit the game by hitting Control Z, or you run out of life, or the owner chicken is dead. Yo, if you run out of owner chicken, you won. You're gonna print out in terminal, of course. So it's gonna handle input, like it's take input from the terminal using UART0. Like after you get the input, you're gonna pass it to C and using switch case to determine which input that you put it in, and you're gonna print out not an act or not. Yeah, you get and you log it like this, so you can know it's acknowledged or not. And after that, it's gonna run into the checking function. You're gonna check a bunch of chicken if they it's gonna check the bullet if it collide with the object, the chicken or the space shuttle, so you can it gonna know it's gonna hit the player or the chicken or not. And also is there a function that make the chicken shoot randomly at you by making a random value and compare it to the compared value, but the compared value can be adjusted with the life of the chicken, so it's going to balance it out during the shooting. And after only checking and after only checking, you're gonna run into the rendering stage. We're gonna clear the back buffer because we're using double buffering in our project to avoid flickering. So it's gonna write everything into the back buffer. And at the final stage, it's gonna copy the back buffer back into the frame buffer of the board. So it's going to avoid flickering, and the back buffer we initialize is initialized globally in the frame buffer using the max setting that we can have in our program, which is full HD. That's a lot. So, and after that, it's going to draw a background because we need background to make it beautiful, and update the everything according to the X or Y move pixel. Is going to update the X and Y coordinate of the object to render. So after it's going to update everything, it's going to draw it. Because we draw it while update. So it's going to update everything and draw it. Like here, draw the game object. And the way we draw the game object is different because we're using the DMA. So the draw of the icon or the image in this game, we're gonna draw line by line. We're gonna clone the DMA line by line vertically. So we're gonna avoid the horizontal time that we get if you're using the CPU. So yeah, it's a little bit faster. And after we draw all of the object, and after we all draw the all object, so we're gonna copy back the back buffer to the real frame buffer. So we're not gonna see any flickering around. And also there is a hard mode, which is rendering the second line of the chicken too. So the the drawback of using the DMI currently I'm facing with is it's only copy, but it doesn't check about the transparency or something else so that I can display it or not. So it's kind of weird. And if you're gonna draw a very like weird hitbox black thingy right here. So that's currently problem we are facing with because the Raspberry Pi it seems like doesn't support transparency value like alpha value. Like right here, we have a bunch of like big image, and each pixel of it have a transparency is 0, but it's still display. So yeah, it's kind of bugged out. And the final one is about the generation of the chicken. So the chicken in this game gonna move left to right. So it's gonna change direction if it hit the barrier of the screen. Like if it hits to this barrier, it's gonna change back. See, back and forth, back and forth, back and forth. And if you Control Z, it's gonna exit the game. So here's a simple explanation of our flow of a game that we're currently developing.
Hello, sir. My name is Trinvo, and I'm the last one to present. So I'll be demonstrating the final task. So this game, I will describe it again. It's called Chicken Invader. So this game has a line of chicken on the top, attack our ship with laser. In order to defeat the game, we will attack them back with our laser. So for this game, I will have a small box on top here to show you what button I will be pressing to play the game. So and also the score and the life that I currently have will be shown on the terminal. All right, in order to hit to start the game, I will type game and then start. All right, so I'm moving to the right with D, right, and then shooting laser with J, to the left with A, up with W, and down with S. Okay, so uh, okay, I can only press one button at a time, and the chicken will shoot randomly. Okay, I almost win. Right, right. Got it. I just won it. All right, no chicken left. I just won, and then I can go to hard mode game. All right, so technically, what's a hard mode has is it has another line of chicken, which is absolutely difficult to play with. So I'm just gonna. It's gonna take time to master. Okay, right. Okay, now I just lost all my lives, so that's it. So this is the end of our demonstration. Thank you for listening.